All right, in this video, I wanted to explain how to use the Pythagorean identity in as we're dealing with the trig functions inside the unit circle, finding values inside that unit circle. So the Pythagorean identity is just a specific version of the Pythagorean theorem, which that is a squared plus b squared equals c squared if we're talking about a right triangle. So a could be either of the short sides, b could be the other short side, and c is always the hypotenuse. So the Pythagorean identity is just a particular version of that. So in our triangle, we've discussed how the horizontal distance can be found using cosine of whatever the angle is, assuming the angle is here. The height, or the y-coordinate, is found using sine, and then our hypotenuse is always 1. So all we're doing here is really replacing a, b, and c with these other values that they're more straightforward, and it's always those values when we're within the unit circle. So instead of our short leg, or one of the short legs, being called a, it'll be called cosine. And that's still squared, that side length is squared. Plus our other leg is sine, and that's also squared, equals the hypotenuse, and this is a 1, or that's just a 1 squared. So this right here is the Pythagorean identity in particular. So for example, when would we use this? I think we have difficulty deciding that. So for example, if I give you cosine of an angle is worth -2/5, and that angle is in let's say the third quadrant, and I want to find the sine of the angle. Oops, equals what? Okay. So I want to find really what's given to us. We need to kind of dissect this first, but I do eventually want to find the sine. So what I'm given is cosine of an angle is worth -2/5. So I would draw a picture in our unit circle. Cosine is -2/5. Negative cosine means it's on the left of the circle. So -2/5 is here. And it says it has to be in the third quadrant. The third quadrant is down in this right corner. So I'm just going to pretend to draw a little triangle here. Okay, so I know, maybe I should rewrite where that -2/5 is. So -2/5 is this part. I need to find this missing side, the y-coordinate really, or the sine value of the angle. We don't know what the angle is, and we really don't need to know what the angle is because I just want to know the other side length of my triangle. So just like I was saying up in the previous part, the side lengths of our right triangle, this is given to us. This is the unknown. We know the hypotenuse is 1. So all we're going to do is plug in and find the missing side of the triangle using the Pythagorean identity. So in the cosine of theta spot, we are given that value is -2/5. Okay, so we're going to replace this entire part with -2/5. That's where cosine was, and that's going to be squared. Okay, so if you see right here, this cosine value right here is just worth -2/5. So those are equal to each other. Plus, I don't know this other short side of my triangle, the leg. So I'm going to call that, either you can call that maybe y, or you can call it sine of our angle. And that's going to also be squared. Oops, my circle doesn't really allow for us to fit in there. I might put this on the other side. Equals 1. Our hypotenuse is always 1. I just moved that from over here to over here because I don't have any more room on this side. But it's still just the two sides of the triangle, the two legs. -2/5 squared plus our unknown squared equals the hypotenuse squared. So it's the same exact idea, as the Pythagorean theorem. So again, I'm going to do this without a calculator and without making things into decimals, just so we can be a little bit more precise. So -2 squared would be a 4. 5 squared is going to be 25, plus our sine of theta squared, which again, I'm just trying to find sine, which is the height, so I really don't need to know what this angle is or what this whole entire big angle is. All right, it's going to equal 1, or I'm going to say 25/25. Oh, can't see that. So if I take away 4/25 from 25/25, I'd have 21/25. That will equal sine squared. If I square root both sides, we want to try to simplify this as much as we can. The square root of 21 we cannot simplify the square root of 21 any further. So we're going to have sine of our angle is worth the square root of 21 over the square root of 25. I can simplify that to just be a regular 5. Okay. Now typically we'd have a positive and a negative for our solution, meaning we may not have enough information to say, is our height going to be negative underground or is it going to be positive? However, in this case, I told us that the angle has to be in the third quadrant, for example. So if the angle has to be in the third quadrant, only one of these values is technically correct for sine. And if you look at the drawing, it'll help you figure out which one that is. Our height or the y-coordinate is underground, so that means we need to have a negative value for our sine. So only the negative one is technically correct in this case. So that's the missing part. Is this the other side of the triangle? So don't let the idea of having it be a sine or a cosine squared in the equation confuse you. If you want to just think of it back up to this as just the side lengths, if this was A, B, and C again, just think of it as that, okay? So we're going to use the Pythagorean identity when we're given either a sine or a cosine value, and we need to find the other one, or we would need to find the coordinates because that would involve both.